That, I think, is all our angle will summarize, I think. If Bailey can't think of any others, I think that's it. That's it? Good. Okay, if Bailey says that's it, then that's it.
Nope, that's not it.
That's not it? What did I miss? I believe that's it. I truly believe that's it. I think that's it. Okay, so those are the things you sort of need to work with. I think there's only, 2 or 3 angle questions on the whole test there, okay? So I'm going to do one right now to make sure life is good for you guys. Okay, and then I'll give you one to practice tonight, and then we'll move on to the exam now. Okay? Here we go. Example 2 we're up to. Let's maybe do this. I believe that's enough to work with there, I believe. You guys want a minute to try this yourselves before I take it up? I'm going to give a hit pause and give you guys a minute to try that yourselves. And that's literally going to be 1 minute because time's taking it. Okay. So remember those funny Greek symbols are, yeah, I think we are. Bailey, can you tell me something interesting about this thing? Tell me one thing that you know. Did you get that?
Opposite.
Okay. So these are opposite. 40 is across from beta, so beta is going to be 40. Lovely. Wonderful. Tremendous. No, you're in. Nick, you're in. Tell me something else you need.
You can do the Z pattern.
Great. Okay, so you can do the Z pattern as a backward Z, but that's okay. So I should probably say beta equals 40 opposite angle. Oh my goodness, sorry guys. Z pattern. All right, great. What can we do next? Hannah, since you already which test, go ahead.
You can do 120 or 180 minus 120.
Oh, good. Okay, so we can do this one here. Call that one 60. All right. Okay. All right. How might that help us? Yeah. Go ahead. From the F pattern. Good. Yeah. Wonderful. Okay. So now you can do this here. That's an upside down F, which is okay. So you can say then that theta equals 60 degrees F. Okay, there's lots of different ways to get this stuff. I wasn't even thinking about that when I made this question. I was thinking going about it a different way, and that's fine. All right? That's right. Question? Right?
No, never mind. Yeah.
You sure?
Well, I was thinking, for some reason, I was thinking, you know how Pat was. Wait, never mind. Never mind.
You sure? Right hand question? No. Your question, very good. Yeah, there's many different ways to get this, right? All right, so. All right, so one homework question if you want one on this. It's going to look something like this. Practice. Okay, can I do one of those? I'll leave one of those for practice for tonight. I don't want to do it right now, okay? So if you remember how you do that, right, you'd say that you'd use 180 n minus 2, right, for that question? Stretching's okay. So you guys should remember to do this one, look back in your notes if you need to, okay, for this one, all right? Yeah, question? Answer. Sorry?
Nope.
All right, I'm going to move on to Pythagorean theorem right now if I can. So I'm gonna sneeze here. Oh. Settle, man. All right, here we go. Thank you.
Interruption. This is Bethune. Would like to announce that this is the last call for pancakes in room 237.
I said you can go if you want to, or you're laughing at my sneeze. Okay, I'm sorry. It's like,
I've
okay,
actually never heard these before.
I don't actually sneeze like that. That was actually a bad one. Let me tell a joke here. When last semester, let's pick one like this. Oh my goodness. Okay, okay, so Pythagorean theorem. Do you guys? I'll hit pause. Give you guys a second to practice this one out right now. Okay. Yes. Go ahead.
Okay, so first you find the first hypotenuse.
Yeah.
A squared plus b squared equals c squared plus
Okay.
10 squared.
Yeah.
100 plus 11 squared, 121 equals 221.
Wait, hold on. I'll call that y just to be things. So you said good stuff there. So you said a squared plus b squared equals c squared. Exactly right. 10 squared plus 11 squared equals y squared. I called that there. So 100 plus 121 equals y squared. 221 equals y squared. All right. Aiden, can you use your calculator, please?
It is 14.87.
And I'm assuming there's lots more decimals in there. Okay. Now let me show you a little trick that we're going to use in a second. And Derek is hopefully going to. Oh, sorry. Go ahead.
Do we even have to do that? Because,
And that's the thing, you can really leave it like this, and I'll talk about it. Mine's going to change back in a minute. All right, Derek, so I'm going to redraw this triangle. You don't have to, okay, but it probably doesn't hurt. Okay, I'm going to put an X there, I'm going to put a 5 there, and I'm going to put a 14.87 there. Okay, so somebody tell me, other than Derek, why that might be helpful for me. You guys are all 3D rotational people, if you can do that in your brains, okay? But normal people have to actually see things in order to do it, okay? So it might be good to write out a second one if you need to. All right. All right, Derek, can you show off your Pythagorean theorem skills again, please?
you go a squared plus b is equal to x squared, which is 5x squared, plus 14.87 squared, plus
Okay, great. And this is what Aiden was saying here. Aiden, can you tell me what's out in the calculator what 14.87 squared is equal? How'd you get that? Right. Okay, right. It was a square root of 221 came from that. You can go right to that number immediately. Yes.
Couldn't you just round up to 14.9?
You could, I'm sure. Okay, right, but you want to be as exact as possible, right? So it'd probably be better for this to leave it as 14.87238.492, right? Because you want to get, like, it's if you do 14.9 squared, you're going to be further away from 221, right? Because you want to get exactly back to 221 when you square it, right? So you want to be as exact as humanly possible. All right, Jenna, what's 25 plus 221, please? Great, what's the square root of 246, please? Okay, good. All's well? Everybody else here? Hopefully masculinely. Pause the video, okay, and then into a sec.